So let's say you want to predict if a certain reaction ultimately is going to be endothermic or exothermic, whether it will absorb heat or release heat. Well, you can kind of do that by considering whether bonds ultimately are going to be broken or formed overall during that process. Recall from two days ago that in order to break a bond, heat is required. Uh, to break bonds is to make a stable compound unstable. And so that is a positive delta H process. Bond enthalpy is the enthalpy required to break a certain type of bond. Every type of bond has a different bond enthalpy. Single bonds require less energy to break than double bonds or triple bonds. Bond enthalpy is the amount of heat required to break those bonds. So you can calculate the enthalpy change for a process, like, say, to go from an individual oxygen atom, monatomic oxygen, and an oxygen molecule, and take those to ozone, where 3 oxygen atoms are bound together. You can predict the enthalpy change during that process by knowing the bond enthalpies of the bonds that will be broken and the bonds that will be formed. So to go from here to here, you would need to break an oxygen-oxygen double bond to make all of the oxygens monoatomic. And then you would need to form an oxygen-oxygen double bond and an oxygen-oxygen single bond. And so to get this whole thing, this overall enthalpy change for the reaction, it is the sum of the enthalpy change required to break the bonds and the negative of the enthalpy change for all the bonds formed. We can kind of see that here. The enthalpy change for the overall reaction is equal to the bond enthalpy of any bonds broken minus the bond enthalpy of any bonds formed. And that's summed up in this overall equation. Delta H for a reaction is equal to the summation of the bond enthalpy of the reactants minus the summation of all the bond enthalpies of the products. Whoa, that's funny. This is reactants minus products. Generally, in most of our other equations, it's products minus reactants, so you'll want to be careful about that when it comes to practicing problems.